Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we are talking about chapter 11.5 relating load, life and reliability, and we are also doing example 11.3. This chapter is taken from the book Shidi Mechanical Engineering Design book, and images is taken from the book itself and from the Google Images. Okay, so this subtopic is start with designer's problem. What is the problem for the designers? The main problem is that the bearing come from the company. You don't design your own bearing unless you work at unless you are working in the design in the bearing factory. Okay, in the bearing, if you are working in the bearing factory, this is no problem for you. But most of us, we are not working in bearing factory. Okay, so we don't design bearing. Okay, we just use bearing. Okay, when we use the bearing, it just like typical uh, when you go into the supermarket. Okay, you go to IKEA, you go to Tesco, you go to any supermarket. This what they have in the supermarket is what you have to only the option that you have to buy. They have many. Let's say this supermarket A have this range of items, and then supermarket B has this range of items. You don't uh, okay. You you cannot design. You just take from the supermarket. Okay, you just buy from the supermarket, and this is what you get. Custom made, you have to go to the factory, to another shop to do the custom made for what you want to do. Okay, this for all other subject you can design. If you're talking about shaft, you're talking about shaft, you're talking about uh, screw. At least you can design. Okay, you can design the structure, but the bearing it come from the company. So the desired load is not the manufacturer's test load or catalog entry. The desired speed is different from the vendor's test speed, and reliability expectation is typically much higher than 0.9 accompanying the catalog entry, meaning that the manufacturers have tested the bearing and everything. They declare this is the test value. Okay, so fine. But what you want to use the same bearing at different speed. Okay, different speed. So you have to, what is the calculation? We learn in this subtopic the relation, what you want what you want to use, the load that you want to use, and the load that the company give. Okay, then you want to choose the suitable bearing for your application. This is what the topic tell about. Okay, so the catalog reliability counter figure 11 5 shows the situation. The catalog information is plot as point A, whose coordinates are log C10 and X10. L10 over L10 is 1. So this is the, again, uh, again, I would like to remind, L10 refers to this. This is the 10. This is the 50 percentile. This is the 90 percentile. Okay, we're talking about L10 is the 10 percentile, like that. Okay, point where 90 is a reliability counter, so you don't go beyond this. Beyond this is very dangerous. Maybe it's prone to failure of the bearing itself. Um, okay, the design point is at D, and coordinates of log F, FD and XD is a point where R goes to RD. Okay, we see the graph after this. Okay, the designer must move from point D to point A by point B as follows. Okay, so this is the equation for it. Okay, FB XB 1 per A. In remember, A equals to uh, application, not application factor, the factor used for ball bearing and also the cylindrical bearing. So A, this equation FB XB 1 over A you can find introduction chapter. If you have the book, you can show, you can see. Okay, just want to remind A here. A for ball bearing is 3 for ball bearing, and A for cylindrical taper bearing, A equals to 10 over 3. Just remember that. Okay. Uh, this is the equation that derived from this, where B is the force from the bearing. Okay, from the catalog, they declare certain force, and D is the desired, what you want. Okay, like say I want the bearing to support 100 Newton, 10,000 Newton. This is what I want. This is the bearing for the catalog. Um, they declare that the bearing can support certain type of load. This also XD is the desired, D is the bearing itself. Okay, so this is the reliability counter. Contour reliability contours point A represent catalog, and you can read it. What I mean is, this is what you desired. Okay, this is the point that you desired. Okay, this is the point that you desired. This is the point that the bearing catalog give. So what is the bearing, suitable bearing for you? You have to plot. Okay, you have to plot. There is a calculation and everything, but basically the idea is what you want to desire and what is the catalog from the, you see the catalog. Okay, and then you can see the bearing that you want. Okay, and then from the calculation that we learn after this, you can, the plot will give you this idea where the suitable bearing for you. Okay, so C10 application factor along constant line AB is referring to the graph itself. RD desired, reliability for desired, expectation this equation. Solving for XB give XB equals to this, and the substitute FB for bearing desired, and noting FB C10 equal to application factor AF with design load. This. Okay, let me remind, application factor is what? Application factor is, there is a table for application factor. You can see in the textbook what is the table. Uh, let's say you want to give application, you want to use this bearing for small load. The application factor is, the value is low. Let's say you want to use the bearing for higher load. Okay, heavy load. Okay, heavy load, the application factor is high. The AF is equivalent to 4, 5, and everything. You, meaning that the bearing that you choose also the most stronger bearing. Okay, this is there is a table in the textbook. You can see the table for application factor. Okay, the application factor serve as a factor of safety to increase the design load, to take into account overload, dynamic loading, and uncertainty. Meaning that, suppose you are designing a bearing. Okay, the bearing is not designed for impact, meaning that God forbid accident happen. Okay, impact. Okay, when accident happen, uh, does your bearing can be safe, or can be used again, or cannot be used again? This is the question. If you already calculate the possibility of an accident to happen, your bearing may be safe. If not, your bearing cannot, may not be safe. Okay. In the equation can be simplified to calculator by noting that ln RD equals to, and you get R 1 minus RD, and P is the probability for failure. Okay, C10 is the equilibrium factor, and you get RD, R equals to more than 0.9. So this is you can go for 90% for probability. Maybe if your application, meaning that uh, you will be rarely open back the bearing, you will be rarely change the bearing. Okay, maybe the application, uh, you use the bearing, and you don't want to do maintenance for a long time, you have to choose the bearing 90 probability. Okay, so for a long time you don't have to do maintenance. Okay, because the bearing is safe. This is why you want to choose probability for 90. And then either 11.9, 11.10 may used to convert for design situation for desired load life reliability to a catalog load rating based on rating life at 90% reliability. Note that RD equals to 9, 0.9, diameter equals to 1. Equation reduced to this. Paper parameter are usually provided in the manufacturer's catalog. Typical values given by on page 001 in the textbook, beginning of the end chapter problem. This is you want to say that 90% probability, you may choose. No problem, you may choose. Okay, and then the the bearing itself is expensive, and but it's okay. If you have the one to application permit you to do that, you go use that 90% probability, no problem. Okay, the bearing on shaft. Generally, shaft generally have two bearing. Okay, often these bearing are different. If the reliability of the shaft is bearing is R, then R related to emitter bearing. RA and RB. What is RA and RB? Now, for a shaft, usually for a shaft they have two bearing. This is bearing A, this is bearing B. Bearing A and bearing B. So equals to RA and RB. Okay, this is a bearing. Okay, both bearing are not the same. Okay, both bearing may be the same, maybe not the same. Okay, so you have to find the relativity for both. Okay, so both is combined. R R equal to R A R B. R A R B. Both. Okay. So you have to calculate for both factor. Calculate for A first, then calculate for B. Then you combine, then use the derivative. Meaning that you can be sure your bearing is safe. Okay, because you consider both situation. If you have three bearing, it becomes CRC, and so on and so on. You have to calculate for all of them. Okay, and then this example for 11.3 design load for ball bearing is, okay, you can read. What does equation 1? Equation 1, what is the C10 catalog entry for the sort to be sort or exit when searching for deep groove bearing in manufacturer catalog? Okay, so given the Weibull parameters is x 0.02, it's not 4.49, and B is 1.483. Okay, it's just like the example 11.2, given the all the parameters here. If you remember example 11.2 is like this. Solve the equation and you can get xd equals to dimensional value, ld desired life, rd, lr is reliability. So you get from the formula you get 540, and design life is 540 times the L10 life. For the bearing A equals to 3, from the equation you can get 6696 pound. Okay, what does this solution means? It means that, okay, it means that when you want to find the bearing suitable for this question, you go to the catalog, you see nearest to the 6,696 pound. Then this is the bearing you choose. The nearest, or slightly stronger than that, maybe 7,000 pound, maybe 6,800 pound. This is the bearing that you choose. Okay, this is the bearing that you choose. Okay, and then the life bearing is 540 times the life, meaning that you can expect the life rating should be longer, and then you can predict when you want to make maintenance, let's say 540 times the life, you calculate the life is in hours, maybe equivalent to 1 year. Okay, after 1 year, you will tell your worker or yourself to do maintenance after 1 year, to change the bearing after 1 year usage. This is meaning by 540 times the life and everything. Okay, so that's all for the video for today. We see you in the next video on chapter 11.6, combined radial and thrust loading. So thank you very much.